science guy.
Wavetastics physics song.
Wavetastics physics.
Wave. Wavetastics physics song. Physics rocks.
Wavetastics physics song.
Waves are a disturbance that carries energy.
Waves. Wavetastics physics song.
EP and JT.
Waves, a disturbance that carries energy. There are so many different characteristics to them. There are so many different kinds. So do you ever wonder what waves really look like? Well, in this ocean in a bottle, you can see that these are transverse waves because it has crests and troughs. Let's dive right in and learn more about transverse waves and the other longitudinal waves.
There are two different types of wave movements. There are transverse waves and longitudinal waves. Today I'll be showing you two different diagrams of each wave to compare and contrast the characteristics between the two of them. So first, transverse waves have crests and troughs. The crest is the top of the wave and a trough is the bottom of the wave. For example, a water wave is a type of transverse wave. And today in the activity with the ocean in the bottle, you could see the crests and the troughs as the wave moved up and down. The next characteristic of a transverse wave is amplitude. Amplitude is the amount of energy in a wave. This can be found from the rest position to either a crest or from the rest position to a trough. The last characteristic of a transverse wave is wavelength. Wavelength is from a crest to a crest or a trough to a trough. Wavelength can also be found using the equation velocity over frequency. Frequency is the amount of waves per second. So the next wave movement is longitudinal waves. Longitudinal waves have rarefaction and compression, and they do not have crests and troughs. So rarefaction is when the wave is spread out, and compression is when the wave is compressed. And similar to a transverse wave, there is wavelength, which is from rarefaction to rarefaction and from compression to compression. And wavelength can also be found using the same equation from the transverse wave, which is wavelength is equal to velocity over frequency. Lastly, the example of a longitudinal wave is sound waves. Thanks for tuning in to Daily Diagram.
Fun fact!
All electromagnetic waves, which are waves that travel through empty space, are transverse waves. Electromagnetic waves include radio waves, microwaves, infrared radiation, visible radiation, ultraviolet radiation, X-rays, and gamma rays.
Whoa! To bounce off that last fun fact, what exactly is a medium? A medium is matter that carries the wave. Mechanical waves are waves that do need a medium to travel through, unlike electromagnetic waves.
For example, ocean waves are carried by water and sound waves are carried by air. Along with those two examples, seismic waves are also mechanical waves. Here's an at-home demonstration you can do with just a slinky. First, set the slinky on a flat surface and lay it between two people. At one end, somebody will push it towards the other end like this. The other person can observe the longitudinal wave moving through the wave. As you can see, compression and rarefaction in the slinky. It is also noticeable that the wave motion and medium motion are parallel.
Fun fact number 2.
The more elastic a medium is, the faster a wave will travel through it. Waves travel through solids the fastest because they are the most elastic mediums. Waves travel through gases the slowest because they are the least elastic medium. Waves travel through liquids in an in-between speed. Now for a transverse wave, all you need to do is move the slinky back and forth like this. You are able to see the crest and trough of the wave move through the slinky. As you can see also here, the medium motion is perpendicular to the wave motion.
Fun fact number 3.
If the frequency of a light wave, which is also a transverse wave, is increased, then the color will change. And if the amplitude of a sound wave is increased, the volume will change. Man, what a day it's been. We've learned so much about transverse and longitudinal waves. Let's go over what we've discussed about the two today. Transverse waves have crests and troughs. They also have perpendicular motion to medium motion. And a good example of transverse waves are water waves, as we showed in the ocean in a bottle. Longitudinal waves have compression and rarefaction. And instead of perpendicular, they have parallel motion to medium motion. And a good example are sound waves. Together, they both have wavelength, frequency, and velocity.
Thanks for tuning in to Wavetastics. See you next time!